Assalamualaikum and a very good afternoon. So today I will continue with subchapter 3.4, construct a network-based intrusion prevention system configuration to help secure a network. So in this subchapter, you will learn to explain the function and operation of IDS and IPS system, to explain the implementation of network-based IPS, and how to configure Cisco span. Okay. Alright, so this is the example of IDS and IPS characteristic. So as you can see here, okay, the first is zero-day attack. Okay, means the IDS and IPS should be able to know. Okay, should be able to detect zero-day attack. So as you can see here, okay, this is the DNS server, web server, all this in the DMZ. Okay, this is a VPN in remote branch, and they have a remote worker using a VPN. So this is where you put your RDS and IPS. Okay, so even if they have a VPN, then they will know the zero-day exploit which attacking the network. Okay, so other than that, it must be able to monitor for attack. Means the IDS have a sensor to know that the intrusion have been done to that particular network, and must be able to detect, okay, in the management console lah, okay, whether the target inside the in the LAN. Okay, so the advantage of IDS, it works passively. Okay, required traffic to be mirrored in order to reach, and does not pass through the IDS unless it is mirrored. Okay, mean if you configure it incorrectly, it does not be mirrored, then they cannot be detected. Okay. Alright, detect, and the other one is should be able to detect and stop attack. Okay, the characteristic of IDS. Okay, if you have put IDS and IPS, but your system IDS cannot detect and cannot stop the attack, it will be a very big problem lah. Okay, because the use of IDS to detect the attack, and the use of the IPS is to prevent the attack, which you want to stop the attack. Okay, so basically IPS usually is implemented in inline mode. Okay, so it monitor layer 3 and layer 4, and it must be able to stop a single packet from which the target, and it can respond immediately. This is the example lah. This is the user. Okay, from the outside target. This is the target. So before it's reached the target, okay, it's been detected in the management console, and go to this one lah. Okay, bucket. Alright, so the similarities between IDS and IPS. So the common similarities is basically is deploy as sensor. Main for detection, they have a sensor. So the sensor usually put in the network system itself. Okay, and it use signature. They have anomaly detection. They have signature based. Okay, so mostly use signature. Okay, pattern to detect pattern. Okay, in network traffic, and this one, it can be atomic pattern with single packet or composite pattern multi packet. Okay, this is the advantage of IDS and the disadvantage of IDS and IPS. So this is mostly a story. So advantage of IDS, it should have no impact on network. Yes, why? Because it just monitor. Okay, so no network impact if there is a sensor valid. Mean if the sensor of IDS fail, okay, the IDS is let's say stop working, it should not affect the network. Why? Because the IDS is just for network tools being deployed to detect the abnormality of the traffic, but it didn't control the traffic. Okay, and so no network impact if there is also overload. Means if there is bit overload with a lot of packet, it also should not have any bottleneck to the network lah. Okay, but the disadvantage of IDS is that response action cannot stop trigger because it just detecting the attack, but it cannot do anything. It just attack and it give the warning, okay, to the in the management control, so that the person responsible should know what to do lah. Okay, correct turning required for response action. Mean if the person in charge didn't do something, so the detection is not is detected, but there's no action taken, and more vulnerable to network insecurity evasion technique. Okay, for the IPS, the advantage is it can stop trigger packet. Why? Because it prevent. Okay, it's not detected, it prevent. So it prevent the action from action of attack. Okay, it can use stream normalization technique. The advantage is sensor issue might affect the network traffic. Why it affect network traffic? Because the sensor do something to stop the attack. So when it stop the attack, it might be blocking a port or blocking a IP address. So when it do this, it might be some services that have been stopped at the same time. Okay, and sensor overloading impact the network. Yes, it will impact the network. Why? Because when it overload, the prevention might be not working correctly. So it will impact the network. Alright. So the next, okay, this is the way how network-based implementation is done. Okay, so basically, there are two types. There are host-based or network-based. Okay, for the network-based lah. Okay, so for the network-based, usually is a cost-effective, advantage, and operating system independent based on the OS independency lah. Okay, the advantage is cannot examine encrypted traffic, must stop malicious traffic prior to arrival at host. Before it's arrive the packet, okay, the attack packet arrive at the host, okay, network base must be able to stop the attack. This is for network base. For host base, okay, the advantage, okay, provide protection specific to host operating system. So host base mean you have a host based or prevention system in the host itself. So mean it might be a workstation, a laptop, okay, a server, okay, so it might be running Windows or it might be running Linux. So then you can should able to provide the specific protection for that specific operating system. Okay, and provide in application level protection up to the application, mean the software installed. Okay, and protect the host after the message is decrypted. Okay, for this advantage is dependent on operating system. Different operating system will have different type of dependency of host space. Okay, and must be installed on all hosts. Okay, this is how the network based sensor is being located. So as you can see, it must be located before the exit to the gateway. So this is the gateway, yeah. This is a router and firewall at the same time. So this is the gateway. So let's say you have a implementation of DMZ. You have a server, a lot of server. So and that in that particular segment, you need to have one sensor. Okay, and let's say you have a corporate network. Okay, you have 2, 3, 4 network different department. So for each every department, you need to have a sensor. Okay, before it go to the gateway, means the gateway for the particular network is this one lah, this router. So before go to this router, they need to have the sensor. Okay, and also between, okay, the corporate to the firewall lah. Okay, to the outer border router lah. Okay, they have one. So as you can see, they have 3. So all this sensor is managed by only one server. So this is the server. So the server usually is not located in the same location of the DMZ. It must be separated. Okay, so if let's say this server is being attacked, the management server for the sensor is not being attacked. So it's located in a different physically and virtually different places. Okay, Okay, this is an example of Cisco IPS solution. So as you can see here, we have Cisco IPS IAM. Okay, this is a little card. Okay, a card only. Okay, you have Cisco ASA. So this is a firewall. This is firewall, and this is expensive. Okay, you also have Cisco IPS sensor. Oh, this is a complete IPS solution. And you also have Cisco Catalyst 6500. Okay, this one usually we use in enterprise. This is for a big DB lah. Okay. Alright. So when you want to implement the IPS, so you need to have a factor to choose which IPS that you need to deploy. So this is among the factors that will affect the IPS sensor selection in deployment. The first, how about the amount of network traffic? Okay, what is the what we call it, the range of the that particular organization. Is this big? Is this small? Okay, it is very large. Okay, then you need to know the network topologies, because different organizations have a different network topology. Okay, so for IPS solution depend on that network topology. Okay, if let's say that particular organization have a lot of routers deployed based on different departments, so you might need to have a lot of IPS. Okay, security budget. Okay, this is very important. Okay, if that particular organization have a little or limited security budget, so we need to make sure the IPS solution is the optimized for that particular organization, but at the same time is able to capture the most important part of the security solution lah, and available security staff to manage IPS. So let's say you manage you recommend that, let's say, have 4 or 5 IPS to be deployed, but if there is no staff to manage, it will be difficult, because the IPS need to be managed. It need to be updated based on the firmware. Okay, because every year they will have a bug in a software that you need to patch the software. Same with the IPS. Okay, this is the advantage and disadvantage of network IPS. Okay, the advantage is a cost effective, not visible on network. Okay, lower process independent. So the disadvantage, it cannot examine encrypted traffic. So if there is a encrypted traffic, they cannot examine. Okay. Alright, and cannot determine whether an attack was successful. Why cannot? Because it's just prevent. To detect is the IDS, prevent detection. Okay, this is the mode of deployment. Mode of deployment. So they have, usually this is what we call inline mode. Inline mode means it's in the same layer. Okay, sorry, in the same flat architecture lah. So you can see you have this you have one which is PC and a PC, so the sensor is between that. So as we call inline. Okay, so mostly we will do is a port mirroring. So port mirroring, we can use Cisco switch port analyzer. Okay, so what the port mirroring use is the Cisco switch. Okay, will copy the traffic, will configure, okay, to sniff the traffic. Okay, and copy the traffic. Okay, example, this is a hub and this is a switch. Okay, so the switch will sniff the traffic. Okay, to mirror the traffic. Okay, this is what they will do, as you can see here. Okay, example, this is the sensor for detection. Okay, this is management server that will get the information for the detection. So this in inline mode, what they do is this particular switch, what they do is they have a source port span, okay, from the user, okay, and they have destination port span. So for egress traffic, we go through the switch, and the switch is configured to mirror the traffic to the other IDS. So it will able to know and to check the traffic lah. So this is the command that we can use to configure Cisco span using intrusion detection. So Cisco span means a Cisco devices, which is a Cisco switches, which able to be configured as a detection, a sensor. Alright, so this is the what we call the command that you can use is monitor session and number source, which is interface and VLAN, or witness destination port is monitor session number destination. So interface VLAN lah. This one tak nampak ya. So show monitor command to verify the span session. So what is the number destination? So this is the port. Use the port. So that's it for 3.4. I will continue with 3.5 in a next video. Thank you very much.